Over 200 million people from all around the world struggle with natural disaster. Out of those 200 million, there are Californians. In fact, according to many local surveys, approximately 65% of Californians don't know any of the risks allocated to their homes.
And that is precisely why we created Georisk, a free and accessible risk monitoring solution for all people. And thus, let's meet the team.
Hi, I'm Joseph.
Hi, I'm Harnoor.
Hi, I'm Johnson. In order to show that our site actually works, we're going to be doing a quick demo. In order to do this, we're going to be generating a random address in California. So this website gives you a random address, and we're going to be clicking this button once. So this is a completely new address. We're going to be copying it into our website Georisk. So the process is extremely easy and simple. All you do is you paste your address into here in order to map your risks.
Georisk is built on a web server on Netlify, connected to a robust Flask blueprint-based backend run on Render using HTML, CSS, JavaScript, and Python, and hosted in public domain via HTTP and WebSocket.
In just a few seconds, the results appear, and you're taken to an interactive map of your area. As we scroll down, Georisk highlights 4 main risk categories: earthquakes, floods, wildfires, and landslides.
First off, let's take a look at our wildfire risk. It shows a low probability with a risk score of 0.05, meaning that the location has very low likelihood of wildfire impacts.
Let's explore the landslide risk section. Here, Georisk pulls data from multiple sources, including FEMA's landslide susceptibility maps, local elevation models, precipitation patterns, and soil composition. In this case, the probability is low, with a combined landslide score of about 0.18 on a 0 to 1 scale. That means the slope and soil conditions in this area suggest only minimal risk. Now let's look at the earthquake risk probability section. Here, the app combines several scientific factors. For this location, the overall score is about 0.45, placing it in the medium risk range.
In addition, as you can see, depending on which parameters have a high normalized score, a recommendation algorithm dynamically adapts to provide accurate advice.
Now, let's take a look at our flood risk probability. The flood risk probability model runs on an XGBoost operating system, which uses advanced gradient boosting to emphasize differences in results. Essentially, it's a way of advanced pattern recognition, and through advanced pattern recognition, it's easy for the model to detect places or situations where flood risk is very high. The combination of all these allow for an accurate risk score. In this case, it'd be 0.484.